Hi guys, welcome to the Astro Dude. In this video, I'm going to be talking about an air-breathing starship for Earth-to-Earth transport. This is a very exciting topic as Earth-to-Earth transport with rockets will make the rocket travel more frequent and expand the market for rockets as rockets become rapidly and fully reusable. As rockets fly more frequently, it'll also make rockets more reliable, kind of like how as planes flew more often, air travel became more reliable, or how automobiles were manufactured more, automobiles became more reliable. So you might be asking, Astro Dude, how do you make air-breathing rockets viable? What technological innovations will allow there for be air-breathing rockets? And why should we use air-breathing rockets? Well, I'll be answering that in this video. The technological innovations that have been happening with air-breathing rockets have been mostly happening with a company in the UK called Reaction Engines. They have a heat exchanger called the HX3, and it's capable of cooling down air from 1,000 degrees Celsius to negative 150 degrees Celsius in 1/100th of a second. And this is very useful because you need highly chilled liquid oxygen for rocket engines. It cools down the air by using many small tubes of pressurized helium coolant, which rapidly cools it down. So that's one of the greatest heat exchangers for air-breathing rockets is the HX3, and it uses thousands of tubes of helium coolant to rapidly cool it down. So that's how the HX3 heat exchanger works. Now you might be asking, when you cool down the air isn't just oxygen. Of course, most of it's nitrogen. So how would you separate the nitrogen from the oxygen? Well, that can be done through fractional distillation of the air. Fractional distillation allows you to separate oxygen from nitrogen. And it separates them through the differences in pressure of oxygen and nitrogen. Now you might be asking, how could this apply to Starship? Starship is going to be used for Earth-to-Earth travel. In theory, Starship can travel to near orbital velocities on its own without the super heavy booster, but that's with no payload. With hundreds of people on board for Earth-to-Earth transport, it would have to be much more efficient. But if you make it air breathing, and you get some of the delta V by using oxygen from the atmosphere, you can greatly reduce the amount of oxidizer it needs to carry, which reduces the mass, which would also mean there would be less fuel needed, which also reduces the mass. And it also would need a much smaller oxidizer tank, which would reduce the dry mass greatly. It could also, when it's re-entering the atmosphere for Earth-to-Earth transport, they could have a modification for Earth-to-Earth transport starships to allow them to glide a greater distance to maximize the distance you can get with the least amount of delta V. You do not need to travel orbital velocities for Earth-to-Earth transport. That's why it would work. You would have to go slightly. You can use Earth-to-Earth transport with Starship and go below orbital velocity at about 15,000 miles per hour would work effectively, and it would give it a range of at least 8,000 kilometers, probably more. Now you might be asking, well, what are the advantages of using Starship as a single stage for Earth-to-Earth transport? Well, it means that it requires greatly less fuel and oxidizer, since the booster uses far greater amount of fuel and oxidizer than the Starship, as it is 20 meters taller than Starship, the super heavy booster. So you greatly reduce the amount of fuel. Also, it reduces complexity, making it more reliable, since reliability will be a huge hurdle for making Earth-to-Earth transport starships possible. You would It would make it more reliable because it would be simpler. It would not need stage separation. It would also require much less engines to get into orbit, rather than relying on 30 engine about 30 engines. At first, you'd only rely on 6 engines. It would use the sea level engines, and then once it gets into the vacuum of space past the Kármán line, it would switch to vacuum engines, which are more efficient. So overall, using an air-breathing Starship would make Earth-to-Earth transport a lot more viable with the Starship system. Thank you for watching this video. I hope to make more videos in the future. Please subscribe, leave a like. If you have any suggestions below, then leave a comment. And goodbye, and have a great day.